going to be an extension of the similar triangles that we finished right before we started reviewing for the midterm. When we proved two triangles similar, what did you guys, and I don't need this written down anywhere, don't worry. When we proved two triangles similar, what did you know about the sides? They are in proportion, yes. And when we cross multiplied, anybody remember those numbers or values there? Those were called my what of the proportion? Means, yeah, means. And the other two? Extremes, yeah. So what I'm going to show you today is a special type of proportion, a special one, where whatever's in for the means will always be the same. And the extremes will be different. It's called a mean proportional, where the means are always the same, extremes are different. So let's try one out before I throw them on triangles. Find the mean proportional between 4 and 16. All right, mean proportional. They're asking me to find what are those means that are exactly the same. All right, I know it's a mean proportional, so the means are the same, and my extremes are different. In this case, the two extremes, 4 and 16. So they're asking you this. 4 times 16 gives you a value. Give me a number I can multiply by itself. That gives me that 4 times 16. And this is how we set it up using a mean proportional. Take a look again. The means are always the same in this. All right, cross multiply. We get x squared equal to, start calling on numbers now. Why not? 1. Of course. Let's try this again. 7. 4 times 16. Hi. 64, thank you. That's all I was looking for. How do I get rid of the squared? 28. Square both sides. They're already, this one's already squared. Square it like this?
No, like the square root.
Square root. Yeah, let's add in our big boy words, right? Square root both sides. And everyone's like, hey, yeah, x equals 8. Great job. Nope. Nope. No. Is 8 times 8 the same as 4 times 16? Yes. Oh, there's another number out there no one's mentioning. 8 times 8 does work. But there's another number out there that I can multiply by itself. That still gives me 64. Positive 8 and negative, what? Negative 8 times negative 8. What do you have? Positive 64. So both work. So I need both in my answer then. All right. So there it is. Positive or negative 8. Let me show you how we're going to use it in triangles now. Right away. Yep, right away. Why not? Sure. Just the first day of a new topic. Why would... All right, let's do this. Let's go back to similar triangles here. What I need you to do first here. Triangle ABC. Please draw it where C is the right angle and AB is the hypotenuse. We just took a midterm, so hopefully this word is familiar. From C, from vertices C, draw an altitude to AB with the correct markings. Altitude. From vertices C, draw an altitude to AB. What markings are you putting on your diagram if I just said that was an altitude? 9? Right angles. And let's call that point of intersection on AB point D. All right, how many triangles are formed in that? How many triangles do I have in that diagram?
3.
Oh, thank you. 3. So I'm going to call this triangle 1, triangle 2, and 3, and you're going to help me find a little relationship between all 3 right now. Let's look at triangle 1 and triangle 3, the big one. They both have what type of angles in them? Right angles. We all know right angles are congruent. Triangle 1 and triangle 3, do they share an angle? Oh boy. Do they share angle? Yeah. All right, what am I trying to push you towards here? What do I know about triangle 1 and 3 then? Similar by what method? Angle, angle. Perfect. So those two are similar. How about triangle 2 and triangle 3? Let's take a look at those two. They both have what type of angles? A right angle. Do they share an angle? Which one? B. So what do I know about these two? Similar by angle, angle. So you guys just proved to me 1 is similar to 3. Triangle 2 is similar to 3. Oh, wait, they're both similar to 3. So what do I know about 1 and 2? Similar to each other. So overall, yes, all 3 triangles are similar. Let's take it another step. What do I know about their sides then? They're in proportion. Now, could you do this though? This is really taking it above and beyond. Let's say I said AD in triangle 1. What would it correspond with in triangle 3? Whew, this is really high level now. Right? AD in triangle 1 would correspond with what in triangle 3? Whew. AC, CB? Huh? I don't know. Having a tough time? Whew, what did AD correspond, right? Because if I'm going to set up a proportion, I got to know what sides match up. Having a little tough time? It's okay if you are. It's okay if you're having a tough time if you don't know if it's AC or CB. Right? You're having a tough time, it's fine. Today, I am going to give you 2 devices that will help you match up these sides appropriately and correctly. The first device I'm going to give you to match up the sides is called Hills. It doesn't have an I in it. All right, you see what I mean. Right, Hills. How do I use this, Hills, to match up sides? It tells me how to set up the proportion. Let's start with H. H is for hypotenuse. Go back to my diagram. What do I mean by the hypotenuse? Because there's actually 3 in there. I got 3 right triangles. I have 3 hypotenuses. Which one do I mean? I'm talking about the hypotenuse in the big right triangle, which would be what segment up here? AB. So when we say H in Hills, we're talking about the hypotenuse in the big right triangle. Over L, which stands for leg. Well, there's a lot of legs in this diagram, right? Which one are we talking about? The one in the big right triangle again. Hypotenuse belongs to the big right triangle. Leg in Hills belongs to it. So which 2 could it be? AC or BC. Which one do you use? Whatever one you have information about. Okay? It's not going to be like, should I use this? Or you're going to have information on one and not the other. All right, ready? This is where the magic comes in now. HL, L for again. So I just put the other leg in there. No! That's the same leg. And you know how you're going to remember it's the same leg? What are these called again in the proportion? These are called the means. And the means are always the same today in the mean proportional. Good? All right, couldn't do this like a couple months ago. What happens when you get fresh hits in there? We'll go. Over. So the legs are the same. S, which stands for segment. All right, let's talk because this is a new term. Remember when you drew your altitude in? Notice what it did to the hypotenuse. Turned it into 2 segments. That's what we refer to. All right, the segments are what the altitude created on the hypotenuse. Ooh. Which one do I use? Depends. Whatever leg you use the segment adjacent or next to it. So for instance, in this proportion, we use leg BC, guess which segment we're going to use? BD. You use the one adjacent to it. All right, so that's Hills. That's a way to match up the side. You take the hypotenuse of the big right triangle, leg of the big right triangle. What did we just discuss about the legs? Legs are always the same value. And then the segment you pick, the one that's adjacent to it. I'm not even going to ask you if you have any questions because we got to do actual with some numbers first. Hills might not work though. Like, what if I don't have enough information to plug it in? Your second device, SAS. All right, your second device is SAS if Hills won't work. S for, okay, we've talked about where the segment's located. Ooh, here's a new one. A? Yeah, altitude. And remember where that was? That's the one drawn to the hypotenuse right here. That's your altitude. Equals A again. Same one or different?
Same.
How many altitudes did we just label? Just one. How can I have two different ones? And hey, come on. And where are these altitudes located? They're the what of the proportion? Means. Means are staying the same. Okay, means are staying the same. There's only one altitude in the diagram, and that's the one drawn to the hypotenuse, everyone. There's not two different ones. Over S for same or the other one? Other one. The extremes are always different. Okay, the altitudes are the same, segments are different in SAS. Questions before we use them. And this is going to be a 2-day topic. So maybe you're not sure even after do the assignment tonight. We got another day of in class to work tomorrow with it. Let's roll. Spin? No, what was that? Pinwheels. Those are pinwheels. All right. Here we go. Our last discussion. How do I know which one of the two to use? How do I know if it's going to be SAS or is it going to be Hills? You just ask yourself one question. Is the altitude involved? Look at my first diagram here. Somebody name what the altitude is. What is the altitude in this diagram? Not how long it is or whatever. I just want to know, name it with letters. What's the altitude in this diagram? The one that is drawn to the perpendicular to the hypotenuse. That is 2. BD. Is BD labeled at all? No. So there is no way I'm going to be able to use SAS. I don't have enough information to plug in for the A's. All right, so I established it's not going to be SAS, so it's got to be Hills. So let's first make sure we know what each letter is again and where to find that value to plug in. So we okay on why I can't use SAS? It's going to be Hills to match up the sides. All right, here we go. Let's start with 23. What's H mean again? Of the big triangle. How long is the hypotenuse of the big triangle? Keep going, man. 12. How'd you get it? She can add. 3 plus 9. Everyone all right where H is? Over. What's L mean again? What's the L stand for? Who? For? Leg. There's 2 up here. Only one's being used. What is it? Y. The BC, there's nothing on it. So why use it? Y. And we just, means are the same, legs are the same, and Hills. Now here's really the only issue you're going to have. Which segment? Because you got 2 of them on here, right? You got AD and you got DC. Which segment do we use in Hills? 12? AD, the one adjacent to it. The one adjacent to the leg we're using. So that's why I'm putting a 3 here and not a 9. And that, look, this is what we did at the beginning of class. This is a mean proportion, isn't it? Means are the same. And that's what Hills and SAS are. Y squared equals 36. And yeah, look, did I make a big deal about plus or minus 6? But anybody going to take issue with that? I hope you do.
Can't have a negative side.
I got a diagram that's got side lengths. Y can't be negative 6. So just positive 6. Final answer. Anything else here? I'm going to do one more and then you got the rest in your groups. All right, next one. Is the altitude involved at all? Labeled 27. Which one's the altitude again? BD. Is there something on it? Okay, so there's going to be a SAS problem. And you'll find out, let's say you made the wrong choice and you did hills, you're going to find out pretty quick you don't have enough information, you don't have a leg for hills. And don't call it another variable, please. All right, S4, 19. Give me one. 12, yep. Over. A4, 25, which is X. There's only one altitude in the diagram, and it's BD. And then what goes in for this other segment? 9? 4. Segments are different. Extremes are different. And now we cross them up. X squared equals 48. Quick reminder what class we're in. Honors, darn right. So I do not want, what would that be? 6.9, probably something on your calculator. Don't care, don't want it. What do I want? Simplest radical form, darn right. Biggest perfect square. 4 is not the biggest perfect square. There's something bigger than 4. When you get it, let me know. 2. Bigger than 4.
16.
16 times
4. Oh, about 3.
3. So x4 square root 3. Leave it in simplest radical form. You and your group have the next 6, and then we'll go over them as a class in about 10 minutes. If the answer is not a whole number, leave it in simplest radical form, please. If it's not a whole number, decide whether it's you don't have it's not like, hey, let's do SAS on this. It's one or the other. From there to get what you had for X. Let's start this off right. Let's go number 20, proportion for A.
4 over X is equal to X over 9.
Am I on the right one? A? Your proportion for A? Where'd the 9 come from?
Oh, I just wrote that apparently.
You good?
I don't know about that one. So it'd be 4 over X, X over 6. Wait, what am I doing?
I don't know.
Yeah, that's a good question.
It's the altitude involved.
Yes, it is.
Somebody get this kid a baguette. Hurry up. Stat.
All right.
He's losing energy. Hurry up.
It'd be X over 6 and 6 over 4.
Okay, good.
And we're gonna get 36 is equal to 4x. And x is gonna be equal to 9.
You good?
I'm sweating.
I know you are. I know you got rattled there, but we all right?
Well, it's cold.
All right. We'll just it's a one timer, hopefully. 16. How about B? 40 over x equals x over 10. Where'd the 10 come from? 50 minus 40. Got to do a little math sometimes, right? Other than just plopping numbers in. And then what do we get for x? 20. Yep, that 400 is a perfect square. No need to break it down. Hopefully people didn't try to do that. All right, how we go? C now. 26.
C is 25 over x equals x over 4.
That's a hills right there. Good work. 25 is the hypotenuse. And then what we get for x, Will?
X equals
10. Yep, square root of 100. Good work so far, everyone. All right, D. 19.
12 over x equals x over 9.
12 over hypotenuse over x equals x over 9. Again, good job using the 9 and not the 3, the one adjacent. This was the one that you did have to break down the square root here. You had x squared equal to 108, and then break it down, and it ended up what being it? What do we have there, Allie? 36 times 3, so 6 radical 3 for x. Good work. And then how about E? 12. 16 over altitude equals altitude over segment. X equals 12. Yep, square root of 144. We're all good. And one more. Let's finish it off strong. 7. I wasn't even paying any attention. Let's try that again. All right. And what do we get for x? 60. Yep. Other than that first one, nice job. Great work. You'll get them next time. Don't be surprised if you have to factor on one of them tonight. Heads up. Okay? Don't be surprised if you have to factor on one of them. Tomorrow night, we go back into the textbook.
Algebra B2.